We're on chapter 5 in your book, and this chapter is about exponential and logarithmic functions. The first section of your book is going to be talking about radicals and rational exponents. So we're going to talk a little bit about radicals. These are radicals. We're going to start talking about nth roots. And nth roots are denoted with this symbol. It's just when we take the root of a number. And what root do we take? Well, it depends on what n is. N can be any number from 2 all the way up to whatever number you want. Okay, it's greater than or equal to 2. N is greater than or equal to 2. And n is also called the index. The index. Okay? C is called the radicand. And this symbol is the radical sign. Okay? Now, for example, if I have the square root of 25, when we have the square root of 25, we want to know the answer, and we only want the non-negative answer, the positive or the principal root. That's what it's called, the positive principal root, because we know that this has 2 different roots. Okay, as we're going to see how we know there's 2 roots. Notice that my index here, my n, this index is 2. When n is 2, we don't write a 2 here. But we know that it's a 2 when there's nothing written there. So this I read as the square root of 25 because there's a 2 here. But we don't write it, okay? So this is the square root of 25. And when I look for the square root of 25, the answer to this is, what number do I multiply by himself to get 25? And these are perfect squares. And when I say perfect square, I like to think about a square. And you know, a square has all sides have the same measure. So when someone says perfect square, I think of a square. And if it's a square, that means that this side from here to here has to measure the same thing as from here to here, and it has to measure the same thing from here to here. All 4 sides have to be equal. So when I think about the square root of 25, I think about a number. And that number I think about, I multiply it by that same number to get 25. So can you tell me what that number is? That number is 5. That means I have a square which is 5 on all sides. And when I look for area, I get 5 times 5, which is 25. That's what a perfect square, or this is what I think about when I think about perfect squares. Okay, it's a number that you multiply by that same number and you get the radicand. So the answer to this would be, if I only want my principal square root, I get my non-negative, okay? Because this number tells me that if I multiply 5 times 5, I get 25, which is my radicand. Okay? What other number can I use to get 25? The other number that exists is -5 times -5. That will also give you 25. That's why sometimes when you see the square root of 25, you'll see that that is equal to plus or minus 5. Because +5 times 5 will give you 25, and -5 times -5 will also give you 25, so you have 2 solutions. But when we're taking square roots like this, we usually only want the principal square root, which is the non-negative value, or the positive square root. Okay? Now, What happens if I have the square root of negative 25? If I want to find out the answer, I would have to think of a number that when I multiply by itself or by that same number, I get negative 25. Now notice when I multiply positive 5 times positive 5, these two numbers have to be the same in order for me to talk about square roots or perfect squares. I get a positive 25, and if I multiply negative 5 times negative 5, I get positive 25. There are no two numbers that I multiply by each one and get negative 25. So this is no solution. This is no solution in the real number system. This doesn't exist. The solution to this problem does not exist in the real number system because I don't have two numbers that I can multiply by to get negative 25, and the two numbers have to be exactly the same numbers like we have here, 5 and 5 or negative 5 and negative 5. I can't do negative 5 times 5. They're not the same number. I have to multiply the same two numbers together. So this would not exist. So from this example, whenever n is even, that means whenever my index is even, which means whenever n is equal to 2, 4, 6, 8, 10, etc., an even number, whenever this index here is an even number, I'm going to have this problem. The number inside here, or C cannot be less than 0. C cannot be negative because I have no solution to it. And that's going to happen for square roots, which is an even root. It's going to happen for fourth roots. For example, the fourth root of 16. That asks you, what number can I multiply by that same exact number 4 times, because this is the fourth root. When we have square root, which is a 2, we multiply twice. When we have fourth root, we multiply 4 times. So what number do I multiply by 4 times and get 16? The answer to that is 2, right? 2 times 2 times 2 times 2 is 16. Therefore, the fourth root of 16 is 2. Because 2 times 2 times 2 times 2 is 16. Okay? So whenever you have an even root, you cannot have a negative radicand. Okay? What happens when I have an odd root? When n is odd, that means when n is 3, 5, 7, 9, etc. Look at what happens. If I have the cube root of 8, the answer to this is, what number do I multiply by himself 3 times and I get an 8? 3 times. So I would have to multiply 2 times 2 times 2. That's what gives you 8. 2 times 2 times 2 gives you 8. Therefore, the cubed root of 8 is 2. Okay? When I have, and in this case, when n is odd, I can't say this is plus or minus 2. Okay? Because if I use negative 2, look at what happens. Negative 2 times negative 2 times negative 2 is negative 8. So I can't say that this is equal to plus minus 2 because it isn't. It's only equal to 2. When this is odd, this is what's going to happen. Okay? You can't say plus or minus. It's only the positive one, because if I say minus, it's wrong. When I multiply -2 times -2 times -2, I get -8, and that's not what my radicand is. My radicand is 8. Okay? So this would be the only answer for this one. Now when I have a cube root, let's say of -27, the answer to this is, what number did I multiply by 3 times to get 27? The answer to that is -3. If I do -3 times -3 times -3, that gives you -27. So then this is equal to -3. -3 is the number that I multiply 3 times by that same number. 3 times 3 times 3, -3, and you get -27. Okay, so notice that it's different when you have your index being an odd number. And what's different is that the radicand, when the index is odd, the radicand can be negative. So when n, or your index, is odd, then the radicand can be less than 0 or negative, because that number exists in the real number system. Okay? So there you have a little introduction on radicals. This you probably learned in Algebra 2 or in algebra even, when you started doing square roots and cubed roots and whatever number root. The two important things here is that when I have an even root, I cannot have a negative as a radicand. And when you have an odd root, you can have a negative radicand. In my next video, we're going to do operations on radicals. I'll see you then.